Hey y'all, Data Guy here. And today, as we have a little sunny snow day, or not a sunny, but a snow day in NYC, I thought it would be very appropriate to make a video doing something cool with Snowflake, since I'm going to be seeing a lot of them today. And what I found was basically a way to make an image recognition app in Snowflake using Snowpark Python, Pytorch, Streamlit, and good old OpenAI for its fantastic API-powered AI services. So what we will be building today is exactly what I just discussed, basically a way for you can give a Snowflake, Snowpark API endpoint some kind of image, and then we're going to use OpenAI's AI powers to actually use it to process the image and give us some recognition of what it contains. So without further ado, let's get into it. Let's get started, and I'll show you how to build this. So one critical thing, everything else is pretty much going to be here within Snowflake, but before you get started, make sure you go to your admin panel. You're going to need to have org admin access and enable Anaconda Python packages. This is going to allow us to actually use all the Python packages that we'll need for this specific little tutorial. Then I'm also going to review the provider terms of service, but that's just bog standard for any Snowflake account. You're also going to want to go create a worksheet and just run a script that's going to create your to create a warehouse, database, and schema. So here I have a warehouse called AI House, a database called Image Rec, and a schema called Image Schema because I have zero creativity. Now, because the rest of the application is actually all in Python and Streamlit, we're going to now kick out of Snowflake. You're going to clone a GitHub repo if you just want to copy and paste the code, or you can follow my kind of guidelines here live, and I'll show you basically how we're going to set up a Python environment using Minikana because this needs to be in Python 3.8 because that's what Snowpark uses to actually run the rest of the code and interact with it. Snowflake is essentially just acting as the backend, but we're going to actually do most of the manipulation and the front end via Streamlit via Python script. So once you download that GitHub directory, and also make sure you install Miniconda, I'll put a link to that install link in the description. What you're going to want to do is open up a terminal from inside that GitHub repo, and then you're going to want to run a series of commands. So the first one we're going to need to run is actually creating a Python environment or a Conda environment using a Snowpark image. So here we're just collecting all the package metadata from a Snowpark supported image. Pressing yes to say, yeah, we're okay with all these things being installed. And then what this will do is just build us a specific environment for this specific project. So once it's finished installed, we're then going to need to activate that environment. So you can see now we are in the activated environment. And then we are going to install all the Snowpark Python pandas tools so we can actually interact with it in kind of a notebook style here. So here, install again, and I'm again going to pause till it's done installing. And then once we've installed all of those, we then have a couple more pip installs to do before we're finally ready to have our environment set up. So we're going to pip install Streamlit. And again, this is just going to install, all the Streamlit packages. So even if you already have it installed, you'll still need to do this for this Conda environment because this is a separate environment we're building just specifically for this use case. So it isn't going to use just your base Python system. You could, but you'd also have to make sure all the packages line up, and that's just kind of annoying. So I'm just creating a separate environment with Conda. And then we'll clear this. Pip install, let's see that. Pip install UUID, and then we are going to pip install OpenAI. And this will just install all the OpenAI packages so that we can interact with OpenAI programmatically. Now that we've got all of our packages installed, what is the actual code we're going to be writing? So the first thing we're going to do is actually create that front end I mentioned before where you can actually upload that image for the image recognition. And for that, we're going to need to create a Streamlit app script. So before we even do anything with Streamlit, got to import all of our good old packages. So import JSON, because we're going to be passing JSON data. That's what REST APIs use implicitly. Pandas, we're going to import some Snowpark specific sessions and functions. Import Streamlit as ST. Import IO here. String IO, this is just kind of a buffer for us to store files before uploading them or sending them to another location. Base64 for some integers, and then UUID so we can create unique identifiers pretty easily. Now, after you have installed those base packages, or just import them into the script, we'll then set some basic Streamlit page configurations. So here we're going to use the page title image recognition Streamlit, wide layout. You can see some menu items here, get help from developer Snowflake, just some basic information here from the creator of this walkthrough dash, just linking back to that GitHub repository. Then we have header, image recognition Snowflake. We have a caption, app developed by Dash, and then just writing Snowpark for Python developer guide for additional resources. Then we'll have a function that's going to create a Snowpark session. So this will allow us to actually execute our Python code within Snowpark. So here we're creating a Snowpark session if one doesn't already exist already. And then we're going to just call that function to create a new or get the existing Snowpark session based on this if-else statement here. Now, after we're done with that, we have quite a large function that I'll walk you through step by step, which is going to be actually uploading our image. So here, uploaded file, so st to file uploader. So one of the things that makes this really easy and possible is the streamlit.fileuploader function. So what this will do is basically just allow us to upload a file without needing to actually define the logic of how it does that. Streamlit handles that, which otherwise would be somewhat of a difficult task, honestly, especially for images. So here, uploaded file, you can accept multiple files false, label visibility hidden, and then as long as the uploaded file isn't blank, then what it's going to do is convert that base image string. So every file actually has a string that just is the bytecode behind the actual pixel images. It's going to convert that into hex values. Then it's going to generate a new image file name and then write that image data into a Snowflake table. So it's going to take that raw bytecode behind the image and write it all into a Snowflake table. Then it's going to call a Snowpark user-defined function to predict the image label. So this is going to use, this is where we're going to have OpenAI actually come in and try and predict the open image based on, so you can see, based on the file. So we're going to pull it into pandas and then use our user-defined function to actually predict the image label. So here we have just some columns, display the uploaded image, and then display predicted label in Snowpark. So just what this will do is just display our initial image, and then it will also display what we think the predicted label is that we've generated using Pytorch to actually say, hey, this is what we think that the image recognition actually is. So this is where that image recognition is in place, where you can upload an image, and this will immediately tell you what that image contains. So now we've got kind of the base functionality of how we're going to structure all this. So this is all we need in this Streamlit script. The next Streamlit script we're going to make is going to be the one that actually is going to generate our recognitions. So let's move over there. So now in this second Streamlit script, where we're actually going to take that image description and then generate a new image off of that. So it'll basically be a fake image that we're going to then compare to the real one. Hopefully our AI will actually make it pretty realistic. And then so what we're going to do here is just import a lot of the same packages. And then we're also going to get our OpenAI API key from our environment variables. So if you don't want to set it as an environment variable, you can hard code it in here. Obviously not best practices, but just going to leave it like this right now so you all don't see my OpenAI key and get a bunch of free OpenAI API use out of it. As much as I love everyone, I can't pay for that, sorry. And then after that, what we'll do is have our, just set some page config again, just again, same thing, image recognition app within Snowflake, set our page title, caption, header, and links to our documentation for this. And then what we will do is have that same functionality to either detect the existing Snowflake session or create a new one if it doesn't already exist, or sorry, Snowpark. And then what we'll do is call a function, to actually make sure that that conducts. Create a markdown, so set this in the markdown, our Streamlit app in the markdown format. And then we are going to have a text box for entering text. And so what this will do is allow us to take that image, so the description of the image we're creating, and then you can feed it into here to create an image based on the description of your favorite animal. So going through step by step, so this is the text input. So it's kind of, this app is split up into two sections. There's one that will do image recognition, and then you can copy and paste that description into this text input, and then this will create an image based off of what your initial image actually was. So here we have calling the OpenAI API endpoint to generate an image based on the user entered text. So here prompt text input, make sure you're using the OpenAI.image.create. And what this will do is create an image of the assigned format, convert that base string into hex code again, create a new image file name, decode it so that we can have an image file with the decoded data similar to before, where it's just the raw text data and byte data behind it, and then also write that into a Snowflake table. So we're again storing that very similar to what we did in the last script, and then using that Snowpark user-defined function to again predict the image label. So you can see here converting it to pandas and then running that script or that user-defined function, which I'll show you in a second. And then here, setting the columns, showing the displayed image from OpenAI, and then the predicted label in Snowpark using Pytorch. And then it will delete that locally generated image file. And that's all we need on the Streamlit side of things. So we have two functions here, one that's going to just predict what an image contains, and then another one that can either use that prediction to create an image, or you can create your own text input and then have this create an image as well, along with a predicted label. So now the next thing we're going to need to do, and you'll notice it was a lot of times I was referring to a Snowflake connection, you're going to need to set your Snowflake connection details in this connection.json file, and that's how it will reference and use your Snowflake credentials across these multiple scripts. But after you've done that, and also make sure you set that environment variable for that OpenAI API key, we are off to the races, and we can start working in Python to actually create the script that's going to string all of this together behind the scenes and have it interact with Snowflake. So once you have your Snowpark, your Streamlit scripts written, you've updated that connection.json with your files, you set your OpenAI key as your environment variable, it's time to actually create our Python script for just executing all this. So choose your favorite notebook editor. The key thing is just choosing the Python kernel that we created earlier. So you can see here, I have that Python kernel, Miniconda, Snowpark image rec. And then within here, you're going to want to have your first cell where you're going to import Snowpark session, import user-defined functions from Snowpark, import just a specific version. Again, a lot of the same tools that we had before, pandas, JSON, cache tools, logging, get logger. This just allows us to read and write to logs and also understand data that's in the cache. And then here, what we're going to do is just establish a secure connection to Snowflake. So here we're opening that connection.json. That's why I said you got to add your values there. And then within here, session builder.configs. So just create using those connection parameters, and then use a SQL simplifier. Then what you're going to want to do is just select the current values for all of your schema database. So this is all scripted out here. And then print your current environment details. So this will just allow us to see, hey, make sure that our environment is actually running okay. And then the cool stuff starts down here. So mobile VNet 3 is what we'll be doing to kind of just fast track our image recognition system. So typically to train an image recognition system, you'd have to upload tons of images, test them, make sure that, hey, these are generating the proper values. Mobile VNet 3 and uploading these files just allows us to completely override all of that, and instead just uploads them all and gives us the ability to run image recognition systems using the work of others. So much easier than trying to create it all yourself. So here we're just doing session.put and uploading all of these into that internal Snowflake session stage. And then what we'll do is actually write our Snowpark code where we're going to use that pre-trained model for image recognition. So within here, clearing packages, clearing imports, uploading, adding those imports for our labels, the VNet 3, VNet 3 large. So this is just all the information contained within that VNet 3 large repository of image data that I was talking about. Add any Python packages from the Snowflake Anaconda channel. So this is why at the beginning of this video, I had you enable Anaconda packages because this is how you'll gain access there. And then here under cache tools, load class mapping, open the file name. So this is going to be the file that we're uploading it, reading it. These are these user-defined functions that we're actually leveraging later on. So here under cache tools, loading the model. So here we're loading Sys, Torch, Torch Vision, AST. These are all just different packages within Python that will allow us to read and interpret the data using existing models, so we don't have to design our own image recognition model. That's where Torch Vision, that's where MobileNet 3, AST, and Sys all come into play to actually just give us the tools to run these image recognition systems right out of the box. And so then, once we're done with that, import our directory name, so just Snowflake import directory, set the directory name, set a model file. So this is just import directory plus that mobile 3 net path. Our classing files, again, this classing file that we uploaded previously, so just the MobileNet 3 data. And then don't really need to worry too much about these. These are just standard deviations, default mean of ImageNet data. This transformations here is going to transfer and normalize the actual image data. So this is just going to make sure that all of our images are set in a standardized way in this standardized format, resizing it to so that, no matter what size image we upload, it all gets condensed down to standard format for the MobileNet 3 to use that it's used to. Then we're going to load the ImageNet mapping. So this is going to allow us to, have that mappings between image and description, load the pre-trained image recognition model as well, configure it for inference. And all inferences here is just a term of saying, hey, we're going to run live data through this trained AI model to, make a prediction, solve a task, and then return our setup model, transformation, standardized transformation, and ImageNet mapping. So we have the class Mabel mapping so we can see image and then description. Then now we have our user-defined function, so image recognition using bytes, setting it to the current session, setting a stage location, and then here we're importing bytes.io, torch, and image. These are, again, just packages that are going to allow us to read the actual underlying bytes, interpret it as an image, and then create an image from those hexadecimal byte code. So here, loading that model, importing the raw hex code from there, convert those image bytes actually into red, green, blue, so it can actually convert the raw code back into an image, and then unsqueeze it, so transforming it into that standardized format, getting the model output, so after it's been standardized into that format, feeding it into that image recognition model, and then what this will do is give us our model output and the human text prediction. And then so here, this output right here is going to take it, squeeze it again to normalize it, and then what this predicted label will be is the output of this model once we've done some just basic cleaning here. So torch, and all this is doing is just a fast way of processing that data. So this is where Pytorch comes in, which is able to say, hey, take that output, normalize it, then give it to me as this predicted label using this cls.idx. So it's reading from the predicted outputs and then sending it to us and then returning that predicted label. So this is the user-defined function that we're actually going to be calling within that Streamlit application. And that is the end of our Python script. So now we will actually need to go back into our Snowflake account and go into SnowSite to just create some tables to actually store that image data and also a staging table to store that uploaded MobileNet v3 files that we're going to be using to actually help us, give us that training and data so we can predict these images. So now back in Snowflake, just make sure you run this script. What this will do is just, again, create those two tables I described. And then we can go back into our Python environment and actually start running through all those fun cells. So here, back in Python or in our Python environment, you're just going to want to run through these notebook cells one by one. So just set all those Python environment variables. Now we're going to create our Snowflake session object. And boom. Now, something that just hung me up here for about 20 minutes that y'all didn't see is to make sure that when you put your org ID into your connection file, use a dash instead of the default dot that it gives you, or you will be mercilessly stuck on an error code that gives you no information at all. So just a fun tip from the data guy there. And that's really the only part that might trip you up here. Just wanted to call that out because it definitely tripped me up. So then here we're just going to upload the MobileNet v3 files as Snowflake internal stage, and then deploy that Snowpark user-defined function. So here's creating that and deploying it within Snowpark. So then once this actually runs, we're ready to start running our Streamlit application. So pop open terminal again, make sure you're in the same directory from before. And so here we're in that same directory, not from your Python environment. You're going to want to run it from here because you don't actually need the Python environment to run this. So here, what we're going to do is streamlit.run Snowpark Pytorch Streamlit image recognition. And this is going to pop up a Snowpark, or sorry, not Snowpark, a Streamlit application. So here we have an Oxen image here that is going to, boom, it's an Ox. Second one, ChatGPT OpenAI, and here we will actually run the other script and use it to send a description and then give us an output of what we think that image would be, which is essentially, just kind of replicating ChatGPT, which is pretty cool. So here, back in our local VS Code, just change the script to run our OpenAI image recognition. And now what we can do is actually just send it a description of our favorite animal. And what it should do is give us a Dolly generated output of what that favorite animal looks like. So switching over the screens here. Now let's have a description. A lazy tortoise that loves to eat leaves. And press enter here. And OpenAI.image no longer exists. So, well, looks like OpenAI deprecated support for OpenAI image, which makes sense because now they've integrated DALL-E 3 as part of the actual ChatGPT app. So, unfortunate here, but this is just essentially replicating ChatGPT anyway, so not a huge deal. I think the cool part is having an image recognition system where you can upload an image and have it actually generate you an output. So sorry for the bit of a letdown here, but I still hope you learned a lot. This was a super interesting project to work through kind of on a snowy day where you gotta stay inside. So check it out. If you like it, let me know in the comments below. But above all else, have a good one, y'all. Data Guy out.